for £1.50.
We're missing one. We're missing Mary. But Mary's just emailed me to say she will be joining. She's just photographing the transit, and then she'll be in the chat. So she'll be with us in a few moments, I would imagine. Depends how fast that space station can get across the moon. Not that it's been across the moon before. People always say to me, they say, have you been and done more photographs of the moon? I've been photographing the damn thing for 50 years. It's not changed. It's not changed one bit. It's still the same phases. The phases haven't changed. I kind of feel repetitive, but then you get this draw that you've got to go out and do something. But last night, folks, I went out with a map, a paper map. Remember paper? It's kind of that stuff you used to write on and stuff like that. I got a paper map and a Dobbo telescope, and I decided to look at the map and identify as many rills and mountains as I could. And I found one called Mons Piton. Now, there's a story behind Piton. Is many years ago, we went to Paris, and we took a Bulgarian family with us because it was a relative of the people that we went with. And they were laughing because Piton in Paris means pedestrians. And he was showing a sign for pitons to go under the ground, under the underpass. And of course, me being Pete, they were calling me Piton. But Piton in Bulgarian means little fat snake, but harmless. So I was known for the rest of the holiday as a little fat snake, but harmless. So when I found Mons Piton on the moon last night, I had to have a little giggle outside. And I should imagine people were thinking, what is he looking at for that telescope while he's laughing? But it was Mons Piton I was looking at. So tonight, folks, we're going to, now I've completely bored you with that. And the moon.
It's not boring at all. It's interesting.
It is. Yeah. You know,
Mount Piton is like a sundial, and if you watch it over the hours when it's catching the sunlight, you see the shadow cast. And if you take lots of images over hours during that evening, you can actually make an animation, and you'll see the sundial moving across the lunar surface.
We learned something. We've learned all about what are we? 9 minutes in, and we've learned about little fat snakes and sundials
on the moon.
On the moon. But yeah, Mary's out photographing the old transit, and
you say, Pete, that it's not changed. Actually, it has. It's further away since you started.
Well, a few millimeters.
I'm
getting smaller.
Yeah,
it must be really big when he was born. I think you should perhaps explain when you said that Mary's outside photographing the old transit, you're not talking about her van.
No. Maybe that's what she meant. I don't know.
Maybe
when looking at the weather at the moment, she's probably got a better chance of doing
Maybe
that.
when she comes back, she'll show us some pictures of a transit van. I don't know.
And also, you took photos with your dinosaur, your Nicosaurus, didn't you?
Well, just to show that a 38 quid camera can still take photographs of the moon.
Yeah, well done.
How many pixels was that, Pete?
1 megapixel.
1 megapixel. Wow. That's it. That's all you need, isn't it?
That's all you need. And it's
Peter, it's not about the size. It's about what you do with them.
Yeah, I'm not going to go down that road.
No, I'm talking about pixels and cameras.
If you start me off, you know I can't control myself, so I'm going to behave. Anyway, so this Winchcombe meteorite, this Winchcombe meteorite. So what questions are we going to be asking Dr. Ashley King?
The question I've got is, wherever the meteorite is discovered, usually that gets the name, doesn't it? So this one is going to be known as the Winchcombe Meteorite officially. But what about the village next door? Do they get to call their meteorite by their village name? Is there going to be a bit of a fight over this? Maybe a little village war?
Well, listeners, we're going to go over to another track. We've got a bit of a problem with the old...
they're always at each other's throat anyway, so don't worry about it.
Fighting over the rocks.
Oh, Pete's frozen.
Ooh.
Peter's frozen.
I've just gone over to...
Can the listeners still hear us?
Do we know, Dave, do we know actually how much... actually fell off the ground?
I'm just going to see what... What's going on in the background here?
I understand.
Talk amongst yourselves about the
probe, but surely it had been sat outside. What if animals had gone near it or something?
Well, as soon as it comes through the atmosphere, it gets contaminated. But they ask that when you do find it, is handle it very, very gently. Don't use your bare hands. Try not to even.
I'm going to have to redo this Zoom computer and come back to you with another track after another track.
Okay, just before this doesn't normally happen. It normally is so smooth. I'm just going to give a shout out to our listeners. If you can still hear us,
that's right. That's right. That's okay. That's fine. No, it's all right. I'd muted you when the
that's okay. That's okay.
For the listeners, it sounds fluid and smooth.
Yeah,
don't worry.
What it was, when you went quiet on us, Derek contacted me and he said we can still hear you. So
we can't now.
Can't now though. That's okay.
We can now because I've just unmuted you again. So.
I was going to add lib.
Ashley, welcome to Astro Radio in the Madhouse tonight. It's one of those nights, very professional.
Sounds like you're having fun.
I was just going to say we don't call it the Madhouse, we call it the Fun House.
The Fun House. So Ashley, you were one of the first on the scene at the Winchcombe Meteorite, I believe, when this fell.
Yeah, I was the second scientist, I guess you would say, to get there. Yeah. So on the Wednesday after the fall, Wednesday evening.
Yeah.
Wednesday evening, I made my dash from London across to Cheltenham or to Winchcombe. Yeah.
So, what drew the residents of the house? What drew their attention to this? Why did they think it was a meteorite, or maybe just somebody had thrown something onto the drive?
So Hannah, the daughter, actually heard the bang. On the Sunday evening, but didn't really think anything of it. And then on on Monday morning, they found. I mean, I guess you've seen the pictures.
Yeah,
a pile of black rocks on their driveway that weren't there on the Sunday, and they sent a message to their. I think they've got at least one son, maybe two sons. So they sort of sent a message to their family WhatsApp group saying, "We've got this stuff. It looks like somebody's turned a barbecue out, but it's February and." It'd be very strange in the Cotswolds for that to be happening. So, and I think one of their sons actually sent them the link to some of the news reports from that because we'd gone onto the press saying, "Yeah, we think there might be meteorites. This is what you do if you find it." And so Rob read some of those and put everything into a bag for us within probably 12 hours of it falling to the earth. So, yeah. So we were very, very lucky that they realized that they didn't know it was a meteorite, but they kind of suspected that could, they were in the right area for it to potentially be a meteorite. We were lucky they didn't just sweep it away.
Yeah, I mean, that is lucky as well. So it wasn't spoiled or anything, the fact that they'd been messing about putting it in a bag, it didn't spoil it at all.
No, it's pretty much one of the freshest meteorite falls that has ever been recovered.
So how important is this to have happened in Britain? Does this happen very often in Britain?
So this is the first meteorite recovered in the UK for 30 years. We have about sort of between 20 and 30 UK meteorites have been recovered or found probably within the last 400 years or so. So no, it doesn't happen very often at all. We probably get several that fall each year, but they're probably very, very small. Yeah. So actually I don't know if any of you saw the fireball on Saturday afternoon.
No, missed it.
Yeah, so there was a daytime fireball with a sonic boom reported and everything. So normally that would tell us. So we think there were probably meteorites fell on Saturday somewhere in the UK, but because the UK was covered by cloud, we basically have no camera footage. There's one video that was recorded from Jersey, and without that information, it's really difficult for us to say exactly where any of that material may be. So that's our challenge at the moment. But potentially, we might have had 2 in 3 weeks, which is
that's incredible.
Really bad. Yeah. So.
What this type of meteorite? I mean, we have a friend who does a lecture on the Apley Bridge meteorite. He lives at Apley Bridge, Russell Parry.
Okay. Yes. Yeah.
What are the differences between the Apley Bridge meteorite and this meteorite in makeup?
So Apley Bridge is what we call an ordinary chondrite. So it's a mixture of rocky type materials. It has these round things in it that we call chondrules that are some of the earliest things that formed in our solar system. And it has things like metal. Worldwide, we have somewhere like 65,000, 70,000 meteorites in our collections, and over 90% of those are ordinary chondrites. So really interesting, but we have a lot of that material. This one is a carbonaceous chondrite, that contains minerals that were formed by water-rock interactions in the early solar system. So it probably formed on an asteroid further away from the sun than, say, Apley Bridge, and it contains really kind of primitive materials that were there 4.6 billion years ago and haven't really been changed since, whereas Apley Bridge has been heated up and had a little bit of processing and things.
Okay, before we go over to let the panel ask you a few questions, we also use this session as meet the astronomer or meet the scientist. So obviously, if you don't mind, we'll ask you some other questions about yourself, about how did you get into, you know, all sorts of questions, don't worry, but we will be kind to you. How did you get into this subject? What led you towards this type of work?
Yeah, that's a good question. So when I was a kid, I wanted to be an astronaut, I think, like lots of kids. And as I kind of went to school and things, I always had my heart set on studying astrophysics, actually. And so I was never really a pilot or anything like that. So I kind of ruled out becoming an astronaut, but I thought I'd do astrophysics. And then I think was when I sort of did my GCSEs and did my A-levels, I got quite into geology. So, things like volcanoes and earthquakes and things got me hooked into that, and I did an A-level in geology. And then when I went to university, I went to Manchester and studied, and it was the first year they ever ran this undergraduate course. So it was geology and planetary science. So I got to do rocks, volcanoes and earthquakes, but I also got to look at volcanoes and earthquakes in space. And so I'd never set out to do meteorites as my job, but as I kind of progressed through that and then went on to do a PhD, you suddenly realize that you can actually spend your life studying meteorites and bits of things that come to us from space.
That's very interesting. So do you live and work in London?
Yes. Yeah. So based at the Natural History Museum.
Yeah. So what professional organizations are you a member of?
So I am a member of the Meteoritical Society. So that's the main group for the meteoriticists. And I'm a fellow of the Royal Astronomical Society as well. So I wouldn't call myself an astronomer, but the RAS do great work with astronomy and geology and things as well. So yeah, so I like to call myself a planetary scientist really, rather than a meteoriticist. Most of my research, most of my work is learning about how did the solar system form? How did we end up with planets like the Earth? And rather than looking with a telescope at other solar systems, I actually just study the material in our own solar system. But our kind of science, what we're trying to get out of it is exactly the same.
So have you got an interest in exoplanets at all?
Yeah, I mean, they're amazing. So the fact that we can see and compare our own solar system to other solar systems is really exciting. And particularly because, I mean, it's such a new, all of planetary science is so new. I guess meteorites is probably one of the oldest components. Being able to, I'm really interested. A lot of my research is geared towards, why does the Earth have water? Why do we have organics? Why did life get started here? And obviously that's important for us here, but that's really important as we start going out and hopefully exploring all these other solar systems and looking at things like exoplanets. Yeah, it's really amazing.
Brilliant. So I'm going to hand you over to the rest of the panel now to ask you for a question. They'll be kind as well. They're a nice bunch. Over to you, Dave.
Very kind. We're always very, very nice. We might want them to come back, so we've got to be nice. No, seriously. Well, before I ask any questions, I want to ask a question on behalf of Derek, who's one of our listeners, regular listeners, I should say. And he asks, just lately, we've had lots of bright fireballs coming through the atmosphere, being picked up by the cameras and so on. And he's wondering, are these possibly part of the same body? Is there something up there that's broken up and we're all of a sudden getting these pieces coming through?
Yes, it is possible. It's really interesting. So we've had 4 bright fireballs over the weekend across the world. It's really interesting. And so I've had a few emails today kind of trying to think about why that might be. You certainly do get breakups of bodies that lead to a kind of spike in the amount of material that came down. And a good example of that is the one of the Aechondrites. There's a spike in the amount of material. So they can go through the sedimentary layers, the geological layers. And I can't remember the exact age, but there's a definite spike in some of the geological layers, a few 100 million years ago, where there's suddenly lots of Aechondrite, ordinary chondrite type material, which would suggest around that time, you had a breakup of that body, and that, you know, preferentially was kind of delivering a higher volume of material to the Earth. So it's interesting. We do normally, and I don't know if it's really completely understood, but we do normally see a kind of spike around springtime in the number of fireballs that we see. Most fireballs don't produce meteorites on the ground, really. Nearly all of them end up with stuff being destroyed in the atmosphere. So yeah, it's really unusual to have certainly 2 in the UK within 3 weeks is really strange. And we've had, this is a carbonaceous chondrite, and it's the first one ever recovered in the UK. But actually, we've had several similar meteorites falling across the world over the last few years. It's been, we're not quite sure exactly what's going on with why we've got that. It's really interesting for me because these are the ones I spend most of my time studying. To have all these fresh materials is fantastic. But yeah, I don't think we fully understand what's going on.
Yeah. I was very impressed with the find, Wishcombe meteorite, the fact that the family collected it as quick as they could the next morning, but they also collected it and protected it.
Yeah.
Obviously, it informed the Natural History Museum pretty quick as well. If somebody happens to find something like this, what is the best way to protect it from the Earth's atmosphere, from the moisture, where it will start bacteriating?
Really the best, because obviously we don't expect people to have things like desiccators and proper storage and things for this, but really just the really simple things like putting it into a cleaned plastic bag, which is what the Wilcock family did, or if you've got some clean aluminium foil, just wrapping it up tightly in foil. What we want to try and avoid, although it's really difficult, is putting your hands on it. It's not the end of the world, but if possible, yeah, you know, our hands are, however clean you are, your hands are greasy. And one of the things that we're really interested in, particularly with carbonaceous chondrites, is things like organic materials and water-bearing minerals as well. And they really modify very quickly in the terrestrial atmosphere. So so just putting it just out of the air, you know, is brilliant. And because, you know, if you put it in a sealed bag, it will degas into that bag. And we can study that gas. That tells us something.
Right.
You know, so that's one of the experiments that's going on right now. Is so lots of the material that we've collected is in glass vials, and we'll probably leave it for a week or so, and then we can extract that gas out and look at the kind of organic components that may be coming off of that, and that will tell us something about what's in that meteorite and how it's changing as it reacts with the atmosphere. Yeah. The other really important thing for us is don't put a magnet on it. For a long time, people said put magnets on these things, but what we've learned is that most meteorites are slightly magnetic. Carbonaceous chondrites aren't normally, but what we've discovered is that many meteorites actually have a kind of magnetic record of what was going on. They record the magnetic field. Some of them record the magnetic field in the disk when the solar system was forming.
Yeah.
Some potentially record magnetic fields that were generated on the asteroid that they came from. And if you put a magnet on it, we lose all of that information. So it's like, you know, putting a magnet on your credit card or something. So we try and dissuade people from doing that.
Taking a picture. Good points. Yeah.
Yeah. So it's one of those things that people always say, oh, meteorites are kind of dense and they're magnetic, and you put a magnet on it. And there's a really beautiful, tiny little meteorite fell in Germany in 2019 called Flensburg. So it's only about 20-gram stone. And it was another one that somebody woke up. It was a daytime fireball, and somebody saw the news reports and they found a black shiny stone on I think it was on his lawn that wasn't there before, and reported it. But unfortunately, he put a magnet on it. And it's a completely unique meteorite. It's really, really interesting, an amazing thing that I've been lucky enough to work with. But unfortunately, we've lost that magnetic record, which probably would have told us a lot about where it came from in the solar system. So we're trying, this is one of our new things, we're trying to dissuade people to not...
Let's put those magnets away, everybody.
Yes, yeah.
Nothing's to be magnetized here.
Yeah.
Well, my knowledge of meteorites, I wouldn't say it's minimal. I've got a reasonable knowledge, but certainly nowhere in the level that you have, of course. But I was going to say, I know of the iron, the stony iron, and the stony meteorites. There's the, I can't even pronounce the words, the chondrites and Aechondrites.
Yeah.
So the chondrites are the ones that we're interested in at the moment. But can we explain why these are so important as opposed to your average iron meteorite?
Yeah, so the chondrites are the meteorites that come from small asteroids. So these are bodies that never accreted to become kind of like protoplanets. And so because they stayed small, they didn't really heat up significantly. Some of them heated up a little bit. Some had enough heat to melt ice and things, but basically nothing's happened to them for 4.6 billion years. They accreted, and they've been going around the sun. And so because they haven't been really heated or modified in any way, they lock up all that information. So all the materials that were there when our solar system formed are retained within these asteroids, and they're retained within the meteorites that come to us. The Aechondrites come from much bigger bodies. So some of them, like the ions and the stony ions, they come from asteroids that you can almost imagine being like a protoplanet. So probably not as big as the Earth or Mars, but getting towards that sort of size. And because they're so big, they actually started to melt. They got hot inside from the radioactive decay, and they started to melt the rocks. And that's how you start making all the iron sinks to the middle to make a core, and you make a boundary, and you make a crust. So you kind of have the structure of a planet there. And we think that there's a generation. There was, we have 8 planets now, but there was probably maybe 100 protoplanets in the disk 4.6 billion years ago that formed really, really quickly. And just in the process of the solar system evolving, they've just been smashed up into lots and lots of bits. And so this is why we end up with ions and stony ions. The other Aechondrite meteorites that we have are the ones that come from Mars. So we have about 200 or so, and they're nearly all basalts. So they're very similar to the types of rock that is erupting out of in Iceland right now. And then we also have about 200 or so lunar meteorites as well. So they're again igneous type rocks on the whole. Some of them are breccias from the surface and things. Yeah, they're also classed as Aechondrites. They come from big bodies where you've had more kind of extensive geological processing going on. So the original components have been reprocessed many times, whereas the chondrites, basically nothing's happened to them.
Good. So I'm going to bring Mary into the chat. Mary's got a very good interest in meteorites, and she was actually one of the people who recorded this on the camera, the Winchcombe Meteor at the time. It wasn't the meteorites as they come through the air, was it? So over to you, Mary.
So I don't know what you've talked about before, but I'm still kind of in disbelief that this meteorite was found so quickly. I honestly cried when we had the Zoom call to tell us that, and the data from our camera was literally useless because the fireball was heading straight at us, so we couldn't get any orbital stuff. But I guess all I can say to people is if they're thinking about setting up a camera, it's really important that as many people do that as possible, because I think there seem to be more fireballs, but that's because there are more cameras. There are doorbell cameras and dash cameras, but unfortunately doorbell cameras and dashboard cameras you can't really do a lot of science with, whereas ones that are in a fixed position you can. So I mean, I was going to kind of ask, what effect do you think it's had on meteorite science having these networks of cameras?
Yeah, that's a really great question, and you're absolutely right. The more cameras we have, the better data we can collect, and the more of these we'll find. So yeah, the picking up more fireballs is definitely related to just the number of cameras that people have, either in a kind of network like UK Mon or UK Fireball network, and just doorbell cameras. And yeah, maybe they're not the best for doing lots of science, but they're still really incredible things to kind of highlight to us that something happened. And that was what was so amazing about Winchcombe, was there were just so many reports. It got picked up. The skies were so clear in the UK. It got picked up by all the networks. There were loads of people who had it on their doorbell. I hadn't even thought about doorbell cameras as a way to do this until then. So many people saw it as well at 10 o'clock on Sunday night. Sorry, I've forgotten what the question was.
Just the importance of having the networks. Really.
Yeah, so as I said, this was the first meteorite recovered in the UK for 30 years. I'm pretty confident that it's not going to be another 30 years before we get the next one. And I think that will be because of the camera networks, because we have pretty good coverage over most of the UK now that unless we're clouded out like we were on Saturday and it's a daylight and it's a daytime fireball, so it's kind of, so the Winchcombe was amazing. We had everything went our way, and the event on Saturday, everything's kind of gone against us, unfortunately. But the more cameras we have, the greater our chances of being able to see these things coming in. And what's really important actually with the camera data is to be able to calculate where material may have fell. So we think, maybe several small meteorites land in the UK. It's a really difficult number to estimate, but maybe several small ones, sort of on the order of 10 grams, maybe a bit smaller, land in the UK each year. But if you imagine you're looking for a golf ball in the UK, you've got almost no chance whatsoever unless you can kind of work out even if you can work out the area where it landed, it's really difficult searching the UK environment for meteorites. But if we see them coming in, at least we stand a chance. So.
And it's quite unusual to actually have an orbit calculation for a fall as well, isn't it?
Yeah, really
I was
amazing.
astonished when I saw the numbers on that. There's only about 1,000 orbits known out of all the meteorites that we have on Earth or something.
There are about, as I said, worldwide we have 65,000, 70,000 meteorites. About 1,200 of those are witnessed falls, so things that were seen to come down. But only about 40 or so actually have a calculated pre-atmospheric orbit.
Gosh.
So it's really, really small. It's really rare. This will be one of, I think this will be the third carbonaceous chondrite with a calculated orbit. I might be wrong. Wow. There aren't many of them. No. So so that's what's really amazing. Yeah, so not only can we calculate the strewn field and where the material may have landed, we can work out where it came from in the solar system. And that gives us just so much more context for these rocks. And normally we have 65,000 meteorites. We've got no idea where they came from. It's just a random collection of rocks. And we can say all sorts of stuff about how they formed, but it's really difficult to provide the context for what's going on in the solar system. For Winchcombe, we have a really nice orbit that takes us out to the kind of outer part of the asteroid belt, so getting towards Jupiter. So we can't say exactly which asteroid, but we know it's coming from kind of, where we'd expect things like organic material and ices to have been present in the disk. And it's really special to have that information for this rock. Yeah.
And great that the collaboration has been set up as well with the UK Falls team, getting the data in a unified format. I know Jim's been working really hard on that.
Yeah,
and
he has.
It was a great case study to test.
It was really amazing. With UK Fall, for those who don't know, so in the UK we have 6 or 7 different camera networks, all working under slightly different acronyms, and it's very confusing for everybody, including me. And so UK Fall, UK Fireball Alliance was it's almost just a brand name, really, to get all of those 6 networks talking to each other, sharing their data, and working out how, if something comes down, can we kind of coordinate ourselves really quickly to recover that meteorite? And so that worked really well. So everybody who contributed, like all the networks contributed data that went into calculating the strewn field and the orbit. So that's amazing. And like we were ready. I don't think we were quite expecting a meteorite to come down anytime soon. But we had things like a draft press release ready on the Monday morning when we decided that we thought there might be meteorites on the ground. We couldn't go searching because of the COVID lockdown, so we couldn't just get over there and look. And but what we could do was go to the BBC or go to the local news with this press release and say, look, we think there's a chance that there are meteorites, and if you find anything that looks unusual, just like get in touch with us and we'll take it from there. And that's exactly how we found, and managed to recover this meteorite. So
yeah. Mary, you wrote an article for the Sky at Night magazine just recently, a month or two ago, where you basically how to set a camera up for meteor detection using a Raspberry Pi and a basic webcam. What is involved in that little project? And our listeners out there worldwide can get involved in this, couldn't they?
Yeah, I mean, my husband co-wrote that article, but wasn't credited in the magazine. But he's written a more detailed one that is you can get to on the Society for Popular Astronomy website. And the initial setting up can be a little bit of a faff, but the UK Mon guys have decided they're going to do all the installations and all of the stuff, and then send out kits to people that aren't tech savvy enough to know how to deal with a Raspberry Pi. Then the idea is once you plug it in and do your first kind of plate solve, because you need to know the star field, otherwise it's a doorbell cam essentially. And once you've got that information, the data just uploads itself every night and it all just runs automatically. You don't have to do anything. But if you like data crunching, you can do all kinds of stuff with it because it's all coded in Python. And there are so many kind of projects out there that people contribute towards on GitHub and stuff with Python. And Mark has got an all-sky camera and 2 of our Pi cameras now automatically make a time lapse every night and automatically upload to YouTube while we're still asleep. And that's all because it's Python. Now I'm talking about this like I know how to do it. My coding is 10 print Mary is an idiot, 20 go to 10. That's the extent of my coding knowledge from ZX81, I think it was. But if you are into that, there's so much stuff out there with these projects that people are working on together, open source projects, I think they're called. And it's just amazing. So you've got this option to do all this really funky stuff and create beautiful graphics and that, or you can just leave it alone and it will send the data to the central repository where people can do the proper analysis themselves.
Sounds great.
It's really good.
It's the lazy way, but my goodness, what a way to do it, just let it do itself. But this is definitely, going to grow, and it's going to bring more people into the project, and therefore more chance of, actually catching something as well, observing something.
One thing that, good evening, Ashley, by the way, I'm Andy. One thing that was really good to see was the amount of press coverage the meteorite got. It was a really big media event, and this is fantastic for the future, because perhaps people will know now what to look for a bit more, and the fact that they can see these things and recover meteorites.
Yeah. So it's been quite a whirlwind for me in particular, but for all of us really. So as I said, we were kind of on the Monday morning, we decided, okay, let's say something. Let's say we think we might have there might be meteorites out there, and the models at that time were kind of predicting something like 50 grams of material on the ground, so pretty small. At the minute, we're currently at about 500 grams. So
wow.
So we've got much more material than the models were predicting. So we kind of did the press just hoping to generate a little bit of interest, and in the hope that somebody might find a little 50-gram stone. I don't think we truly believed that we would quite get 300 grams found on somebody's driveway quite like that. And then yes, we were really lucky that the press. I mean, there was a lot of news in the week that week. There was lots of stuff going on in the press, but it got picked up all over the place. And it's amazing coverage for just planetary science. And we're obviously really excited about doing the science.
Yeah, of course.
Sample, but particularly because we're the museum, we're equally kind of excited about the story that we can tell, and how we can get people interested in astronomy and planetary science. That's just as important to us.
Oh, absolutely, absolutely. Do you have any idea yet of how big the object was before it broke up? Are you able to do that yet?
The last estimate I saw was something on the order of about 100 kilos.
Wow, that's big.
But it's very soft material, so we got very lucky that it survived. So it actually made any of it made it down to the ground. And part of the reason for that is it was going relatively slowly. So it was only about 13, 14 kilometers per second as it came in. So that's at the lower end. So if it had been going much quicker, chances are we wouldn't have had too much material actually making it down. So.
Well, I was very lucky last week because I saw a really bright fireball. I stepped outside the house at 2 o'clock in the morning, looked up and immediately saw a fireball.
Yeah.
And I'm in Spain. And so I submitted a report, and I've just been looking at it, and it was seen from Spain, the south of France and Corsica. So it was going eastwards over the Mediterranean. It was absolutely thrilling.
Yeah,
and I knew it was some distance because I saw it touch the horizon. So I thought, oh, that's some distance off. Wow. But it was amazing. It was the first fireball I'd seen in years. I saw a wonderful daytime fireball a few years ago, again from where I live. I just came out the station in the evening, looked up, and there it was. I seem to be very lucky with fireballs in broad daylight. It was quite amazing.
Yeah, they happen. They happen during daytime. You just don't really see them.
Well, you know that us astronomers, we've got this hinge in the back of our neck. So, we're constantly, we step outside anywhere, we automatically look up at the sky. So yeah. Oh, great. Thanks. I think Rachel had a few questions, didn't you, Rachel, about what happened after the material was collected?
Andy, we'll come back to Rachel in a moment. If we just get a moment. A lot of comments coming in from our listeners. Tian over in Tokyo, he says it was in their local papers. So this is how far the news has spread.
Yeah, wow. It's amazing.
So that's amazing in itself. This is worldwide, isn't it? Which is really cool.
Well, I think there was a meteorite fall recovered in Japan last year in Tokyo, I think. I think it hit a building. That's how they found it. It actually hit the side of a building. I think it was last year.
Is this the ricochet meteorite?
Yeah, it does happen from time to time. Yeah. It makes finding them much easier.
Yeah. Stefan in Moscow, he asks the question that, as you say, about it hitting the building and bouncing off. It's a small chance, but how much damage would that cause to a person if it hit them? Basically, this meteorite that was found on the floor, if somebody happened to be standing there at that point, was the meteorite coming in at a great velocity, or was it in free fall?
Yes, free fall. They fall out. So the fireball you see is really high up, and then they fall maybe 30, 40 kilometers or so out of the sky. So that's what we call the dark flight. And that's where we can't see it. We can't track it in any way. And that's where the modeling begins.
Yeah.
So on that Monday morning, we released a strewn field, but it was a really big area. And it was just based on, this is where it would go if there was no wind or no weather or whatever. But we really didn't know that. And so it took us a few days, or took the team, not me, but a few days to actually narrow that strewn field down, because we were really lucky again that the weather was very good and really still. So things can get blown off quite easily. And so so a few buildings have been hit. There's been some things that have gone through cars and things. Winchcombe, Rob, so said that normally his car would be parked on the bit of the driveway that it clipped, and for whatever reason he hadn't put his car there. And normally when that happens, the car is worth much more than the meteor.
Well, that's exactly that car that was hit by the meteor went for auction, and it sold for a hell of a lot of money, a lot of dollars at the time. Yeah.
So one person has been hit, and I can't remember her name, but it was in the US, and it went through her roof, and she was laying in her bed, and it kind of hit her on the stomach, and she had a massive bruise.
Yeah, I've seen the photo of that bruise. 1965, I think it was. If you remember.
Okay, that's something sounds about right. Yeah.
So Tian over in Japan, he says the one in Japan was 18 months ago. And it did hit a building. So
I vaguely remember the reports.
Yeah. Rob in Southampton, he's sure that he saw the daylight one a few days ago.
Mm-hmm.
So that'd be interesting to hear a report
get
from
onto
him.
The International Meteor Organization and report it, because we don't really have any camera information. The more people that can report it to us, the better. So we have loads of reports from northern France, because the skies were really clear there. And as I said, this is happening in the upper atmosphere, so you can see it. But in the UK, we've basically, there have been no reports whatsoever, apart from the sonic boom that people heard. Because it was just really cloudy. So if you did see it, please go and report it to UK Mon or somebody, because we don't have much information to go off. So everything kind of is crucial to us at the moment.
So one from Derek again. Who do the meteorites actually belong to when they land on the ground, and how much are they worth? I mean, that's a question people always, how much is it worth? Scientifically, it's worth a hell of a lot more than it is.
So scientifically, it's completely priceless. And particularly this one, because it's such a rare type and it's so fresh and unaltered by the atmosphere. I'm not actually. We don't comment at the museum on the value of meteorites. Some are worth more than others, but they're probably not worth anywhere near as much as some people. Certainly, some of the things you can read in the papers that give you that impression. But they
things are only worth what people are willing to pay.
It's a little bit like that, and where they come from and things. And so, a Martian meteorite, they tend to be the most expensive things that we have. But the meteorite belongs to the landowner.
Yeah, so if it was to land on a farm, like the Appley Bridge meteorite that landed in one of the farms, not far from where I live, and so that would actually belong to the farmer.
Yes,
it's not as if it's crown property, is it? So
we've got, as I said, we've got about getting up towards half a kilo of material now. About 300 grams of that came from the Wilcox Drive and their front garden, because it exploded into lots of pieces. But we also have a few other stones that have been found by other people in the local area. And there's one stone, which is about 150 grams, which actually split into two when they picked it up, that was found by the search team from the University of Glasgow on a farm. So yes, they found it, but it belonged to the farm.
The owner. Great. So Al from San Antonio in Texas, he is a police officer, and he says that they had about 10 daylight meteors reported last year.
So hello to San Antonio. I love San Antonio. I've been a few times. I'm normally
say hi to Al.
Normally. So last week was the Lunar and Planetary Science Conference, which is the big kind of NASA Planetary Science Conference, which is held in Houston every year. So normally this time of year I'm in Texas. We get thousands of fireballs each year across the world. So they're not common, but they're not unusual, if you see what I mean. So
are they sort of distributed evenly in latitude? Is there any preference for where they're found, or I would expect it to be purely random?
Yes, I think pretty much random.
Okay, Rachel, you had a question. Do you want to read your question out, or?
Yeah, well, I said I'm uneducated on meteorites, but I've only really got into astronomy in the last sort of 18 months. So I was just wondering if you could talk me through sort of from finding it to sort of collecting it and like storage in it, what sort of conditions they have to be kept in, and does that differ on the makeup of the meteorite, or are they all sort of a bog standard protection and storage regime?
Yes, any meteorite fall that would be recovered as quickly as this, we would try and store in something that minimizes its kind of exposure to the terrestrial atmosphere. So meteorite falls are really, recovered falls are really rare. So nearly 90-something% of all of our meteorites are what we call finds. These are things that people have either just got lucky and come across, and there are a few UK ones like that where a farmer was ploughing their field and they found a lump of iron metal that's a piece of meteorite, but most of them come from desert environments. So either hot deserts, kind of Africa or Australia, or places in the US, or Antarctica. So that's a really great place to find meteorites. The problem with those ones, well, not a problem, but the disadvantage of those ones is that they've probably been sat there for thousands, if not millions of years, kept pretty pristine because they're in a desert, but still modified to some extent. So those ones do go into kind of, we do curate them as well as we can, but they're maybe not quite such a high priority as a fall. So for this one, particularly because it's a carbonaceous chondrite, and it's almost like a sponge. As soon as it hits the atmosphere, it starts sucking up all the moisture in the air, and that will actually react with the minerals and start things changing really quickly. So what we've done is put everything into, we have kind of sterilized bags and things, sterilized glass vials, everything's sealed within those. We've got hundreds and hundreds of small stones. So it's been a bit of a kind of curation. It's really good in some ways because it makes it easier for us to distribute the material to other scientists, but it's also quite a headache for us to kind of work out how much material we've got, which was collected, what material was collected on day one, what was collected a week after. And then, so everything's kind of in its special bags, and then they're stored at the moment within desiccators. So these basically it's a box that has a temperature and humidity control, and we can monitor that. And some of them are in kind of sealed bags that have oxygen scavengers in them, so they actually there should be no oxygen at all reacting with any of the minerals. So that's our first thing at the moment, and we've got like 2 boxes worth of winchcombe, and our plan is to probably get a nitrogen purged glove box. So and with that we'll be able to actually store it in there, but also it will have 2 like gloves you can put your arms in. So you've probably seen the people at NASA and something doing these with the lunar thing. So we'll probably get something like that, so we can actually do all the curation under a nitrogen environment rather than in air. So that's kind of the plan. We might do some fun things. There's a meteorite called Tagish Lake that fell in Canada in 2002, and that actually fell into ice. It was like snow in a lake, and some of that meteorite has been kept in that ice ever since it landed. So we might, obviously this hasn't happened for winchcombe, but we might freeze some of it and then go back maybe in 5 years to see how that's kind of been curated compared to something that's been left in a desiccator. So there's lots of fun science we can do about answering questions about, where did water come from on the Earth? Where did organic materials come from? But also lots of interesting kind of curation work that we can learn from having fresh material like this. And that's really important as we start getting towards asteroid sample return. So hopefully many of you saw that Ryugu came back, or bits of Hayabusa 2 brought back pieces of asteroid Ryugu last December, and the analysis for that will start in a month or 2. And then in 2023, we've got pieces of Bennu will come back with OSIRIS-REx, the NASA mission. And those materials from Ryugu and Bennu are going to be really similar, we think, to the meteorite, to winchcombe. So winchcombe's like a kind of test run for us to get all of our procedures in place so that when we study the things that space agencies have spent billions of dollars going to collect, we can actually, we know what we're doing when we do that. And then kind of longer term, with China have just brought back samples from the moon, and in 10 years, maybe we might have sample return from Mars. So curation is kind of just as important for us as doing the kind of science.
Well, thank you.
Okay, so just before we go around the panel again, Martin in Alaska says he found a small meteorite in the snowfall. So that's out in Alaska, and it was just sitting. But when they're in the snow, they actually stand out easier, don't they? Especially with the black.
Yeah, so that's one of the
an eye.
Excuse me. One of the advantages of going to Antarctica, for example, is it's a black, relatively shiny rock sat on an ice sheet, so it makes it much easier to find. Chelyabinsk is another one because that obviously that exploded into lots of pieces, and lots of that fell into snow, and it made these kind of little impact kind of tracks within the snow, and that's how you could actually, people when going out searching could see these little sort of divots in the snow, and then put their hand in and pull out a tiny little piece of Chelyabinsk. So yeah.
Of course, the great thing about that particular meteor, as it came through the atmosphere, so many cameras picked it up because in Russia it was a thing. It's become the way to have cameras in the car wherever you are. Your camera's always on.
Yeah.
That's now become the way in the UK as well.
Yeah, so for Winchcombe there was lots of dash cam footage and doorbell footage as well. So everybody's got a camera somewhere on them. Yeah.
So even on a cloudy day, as long as that meteor is seen coming through the atmosphere from different angles, different directions, and wherever you are, you can triangulate the path.
Yeah,
so it doesn't have to be clear, nice against the background stars. In that case.
No, this is
amazing.
Yeah, the more cameras you have, the more chance you have that one of them will be able to pick it up, even if it's cloudy. So
I've got a feeling in the next year or two you're going to be inundated with lots of meteor wrongs, maybe, but a few meteorites.
Well, that's all right. We're happy. We want people to send us pictures. We get lots of people saying, "We're really sorry, don't want to waste your time."
Don't waste your time.
We want people to send us the pictures. I mean, 99% of them are not going to be meteorites, but we will look at them and we will get back to you.
But the magnets, it sticks to it. It must be a meteorite.
Yeah.
Sorry, there's lots of earth rocks that actually have iron in them.
Yeah, and particularly in the UK, we've got such an industrial heritage that there's lots of bits of slag and coal and things out there.
I love that word.
Like meteorites.
Northern slag. There we go. Right, let's go around the panel. Daz, you got your hand up there.
Hi, Ashley. Hi. Nice to meet you. You were talking about the sealing them in the bags and everything, and that the gases will be leaching out. When you come to examine these gases and analyze them, what sort of gases will you be looking for? And will you be looking for long chain molecules as well?
Yeah, so that's a good question. So, yes. So, I'm not an organic chemist, so this isn't quite my area. But yeah, we will look for things that any kind of complex or relatively complex organic molecule, long chain things are in there, will absolutely be of interest. And then we'll measure things like, helium, neon, argon, the typical noble gases as well will be a high priority for us as well to see what's coming off. And then, any way that sort of carbon, hydrogen, nitrogen, oxygen bond together is really interesting for us.
Yeah, the only reason I ask is that they've sniffed and detected these sort of long chain molecules around asteroids and things like that. And of course, it adds to the panspermia idea that life was brought to Earth from comets and things like that.
Yeah, so the building blocks. So
it would be interesting to see what you can actually find out from this.
It'll be really. I mean, we know that these types of meteorites do contain these kind of things like amino acids that they've been detected before. The challenge has always been how much of that is from the asteroid and how much of that is terrestrial. And when you get a chance like this to study something that was collected within 12 hours, we'll be able to be much more confident about what's terrestrial, what's not. And also because we have material that was collected really quickly, but we also have material that was collected, a few days later, and some material that was collected up to a week, maybe slightly longer than the week, we can actually compare between the different, and we know, some was found on a drive, some was found in a farmer's field. We've been really lucky with the weather. It hadn't really rained. It was quite foggy when I was there, but it didn't really rain. So, but we can do all these kind of comparisons and see, how this material, because it will change really quickly. It will change. Anything that there's probably more material out there, but it's not going to survive for very long. So it's part of the reason we don't have a carbonaceous chondrite in the UK before, is if you don't find it quickly, it won't hang around in our climate for very long without being significantly modified and changed.
Oh, thank you for that. Thank you.
Right.
Thank you very much. Michael.
Hi, thanks, Dave. Thanks, Ashley, for that. Was great. Just a quick one. The Natural History Museum itself, could you outline the role of the Natural History Museum regarding the meteorites? For instance, is the museum basically the UK coordinator for meteorites in this country?
Yeah, so we curate the national collection of meteorites at the Natural History Museum. So we have about 5,000 different pieces from about 2,000 different meteorites. It's one of the oldest collections in the world. It's not the biggest anymore. It used to be. It's nowhere near being the biggest anymore. But we do have some of the, I think we have more Martian meteorites than most collections. We have more witnessed falls than most collections as well. So yeah, we're kind of the repository for the UK meteorite collection.
Yeah. Sorry. So, as the repository, can scientists, request samples of meteorite for research? Yes. Is that how it works?
Yes, that's exactly how it works. Yeah. So our collection is available for research and outreach and education. So I'm not the curator, so I couldn't tell you how many loan requests we get each year and how many samples. But yes, we have a kind of catalogue of what we have available, and people write us like a proposal saying we want to do this, and we organize and send those samples out. So yeah, and the same way, I mean, I'm a research scientist, so I approach, I used to work in Chicago at the Field Museum. They have a great collection there. So I'll write a letter to them saying I want this sample, or you write to, so we talked about the Antarctic searching. So that's a NASA facility. So, a lot of my samples come from them. So yeah, so
obviously other countries as well, scientists from other countries can apply for.
Absolutely, yeah, it's an international thing. So Winchcombe, our plan is, because it's such a special event for the UK, that at least initially for the first sort of 6 months or so, and because we have such expertise actually in studying meteorites in the UK, already really well established. So there's the Natural History Museum, but there's the Open University, Manchester University, Glasgow University, Kent, Plymouth. We have real strength in this area already. So the initial analysis phase will be done by a UK consortium. So we're curating the materials, but over the next few weeks, we'll be distributing them to the different labs, and we all specialize in, so we do mineralogy really at the museum, but Manchester do noble gases. Glasgow are measuring organic things right this second. So we'll all kind of do our special thing and pull all that information together, but it will be available in the future for international scientists. And
yeah, so you'll be getting a sample for your own research as well.
Yes, yeah. I mean, these are the things that I've spent my entire career looking at. Yeah. So yeah, I'm particularly interested in this.
What sort of size would that sample be that you'd guess?
For my research?
Yeah.
So I normally I could work on a kind of grain of sand, and I could do a lot of science with that. And that's normally when we have sample return missions. So for example, Hayabusa 2, we have about 5 grams of material from Asteroid.
Right. Yeah.
The target for that mission was 0.1 grams, and that would have kept us going for decades. So to have 5 grams is incredible, and then we've suddenly got half a kilo of stuff from it. It's a meteorite. So honestly, I mean, a lot of what I do is kind of I go to the diamond light source quite a lot, which is the synchrotron facility in the UK, and we use really high energy X-rays focused down into really small spot sizes, and so we can study the mineralogy and the chemistry of, as I said, like a grain of sand. Really. But also I do some kind of bulk work as well. So they're normally sort of 50 milligrams or so in size. So they're quite small chips. So nothing big.
Okay.
And what we try and do is do correlated analysis. So where, particularly for something like this, we'll try and do lots of non-destructive things first. So we'll take a chip and we can do something like a computed tomography, CT scanning, and we can actually look at what's inside that. And then we can think about, can we do something like infrared spectroscopy on the same material and correlate that with the CT? And then can we put that in an electron microscope and correlate that with the CT? Can we do X-ray diffraction? We try and do lots of non-destructive things first. And then there are certain things like isotope measurements where we have to destroy the material.
So, okay, thanks.
Sorry, just before sorry, I was muted for a second. Before we go to Roger, one of our listeners in Iran, he calls himself John for various reasons. It's maybe a political thing, but he tends to not use his real name, as is the way. But he asks, are there many finds in desert landscapes? We always hear of Antarctica or the Arctic. What about desert type landscapes?
Yes, yeah. Lots of meteorites come out of the hot deserts. In particular, kind of Morocco and kind of those areas, we call them NWA, Northwest African meteorites. Lots of material comes out of there. So yeah, they're great environments, again, for finding kind of dark black rocks. They really stand out on the desert environment. And depending on some deserts, their kind of climate has changed over the last, over Earth's history. So some clearly, not all deserts are the same, basically. They've got slightly different climate histories. And so that's reflected in the kind of weathering of the meteorites. So one of the new places to go at the moment is the Atacama Desert in Chile, because it's really high altitude. So it's incredibly dry, but it's had a very different climate, say, to Northwest Africa. And you can see that there are variations in how these meteorites have been weathered over time. And you can kind of track that. The Antarctic ones tend to be, for finds, they're about as pristine as we can get, really. So, but they have been modified to some extent.
Yeah. In desert conditions, lower ground level, would you get much erosion due to the wind and the abrasive effect of the sand?
Yeah, you can. So there's one of my meteorites, one of my favorites, that we have a nice piece of at the museum, which is it's called the same type as the Winchcombe meteorite, we think. It's called Giblet Winselwan. It's got an excellent name. And so this was found in Morocco. And I remember we bought it we bought a big chunk of it, and we have a nice piece of it at the museum. And I got my little 50 milligram fragment to do my research on. And when I broke that piece, it's full of cracks. And as soon as you open it up, sand just fell out of all these cracks. Yeah, really amazing. So, and that has a very low weathering grade. It's quite a fresh find. So it's probably been there for thousands of years, but it's pretty fresh compared to some. But yes, things like the wind and things, and new minerals form. So there's a mineral called, so what we often find in carbonaceous chondrites in finds is sulfate minerals, things like gypsum. So they're like plaster of Paris. And then that's the kind of moisture in the air reacting with the sulfur in the rock. And you get this white veining. And then what I found in Giblet Winselwan was a mineral called anhydrite, which is what happens to gypsum when you heat it up to sort of above 30, 40 degrees. And that's probably the desert environment causing that process. So yeah, so it's interesting. We can learn lots about weathering, actually, from studying desert things and comparing it to the weathering that's going on in the Antarctica. So some Antarctic meteorites have elevated abundances of kind of sodium and chlorine, because there's like the seawater gets swept onto the ice sheets and things. And so their element iodine as well, their elemental abundances are modified by that. So
there's a heck of a lot to take into consideration, isn't it?
Yeah.
To get those pristine samples is very important.
Yeah, so we can kind of rule nearly everything out for these for Winchcombe.
Yeah. Okay, let's get back onto our panel. Roger, you have a question?
And good evening. I was just thinking that with the age of the Winchcombe meteorites, will there be any background radiation from the millennia that it's been up into space that you would still be able to get any trace elements of?
So all the original kind of anything radioactive that was there at the birth of the solar system is probably gone by now, pretty much. But what happens when these objects are in space, particularly when it gets knocked off an asteroid, is they're exposed to radiation from the sun. And that can generate certain elements that have very short half-lives. So these are what we call short-lived cosmogenic nuclides. And so when it's in space, it gets irradiated, and those elements kind of build up. And then as soon as it comes through the atmosphere, it's shielded from that. So all those elements start decaying away really, really quickly. And some of those have half-lives that are on the order of days. And so that's, along with the organics, that has been our priority for the measurement, is to count that radioactive decay. So it's just gamma counting. So some of that has gone up to Glasgow and is being counted right now. Some of that is going, I put it in the post today. So some of it's going to America, some of it's going to Italy. And so what they'll do in Italy is actually they'll measure this underground because the irradiation is really low level. So it's there, but it's very, very low. So if you go underground, you have basically no background. And what they'll do is they'll just count how much is there. And then from that, we can work out how long that object was in space for. So we can give a rough age for the time that object was knocked off of the parent body to it arriving on Earth. And we can estimate how big that object may have been as well. So it's really important. We don't get to do that for very many meteorites. And I have to admit, I'm not an expert in that kind of those measurements, but so it's been fun for me to learn very quickly about that and try and work out the best places in the world to actually count that. But it's really important information for telling it. From the camera networks, we can kind of estimate that, as I said, it's about 100 kilos, but the models aren't always right. So it'll be really interesting to compare that data.
Thank you
very much. Simon, any thoughts, questions about the subject?
Hi, actually. Given the volumes, what are the plans to actually getting it out on public display? So you have so much material. When can people actually, because you've created a massive buzz and a spark, well, all the cameras did, be a shame not to actually allow people to see it and have it locked away in a lab for many years to come.
Yeah, it's mine now. Nobody gets to see it. Yeah. I had it, honestly. I went to collect it. I went over on the Wednesday. So Richard Greenwood from the Open University was he lives in Oxford, which isn't that far away. So he could drive over to meet the Wilcox because we'd seen the pictures, and honestly, when I first saw the pictures, I wasn't 100% convinced, which is why I didn't immediately dash over there. But Richard drove over, and he was the first sort of scientist on the scene. And I got a phone call Wednesday afternoon from him saying, this is a carbonaceous chondrite. So I literally just left my flat and got across there and went and met them that evening. And I really didn't know what to expect or anything. And we sat outside for like 3 hours, and on a Wednesday evening in February or March, I guess. And really, they've been absolutely brilliant to work with. And they put it in these bags, and they just wanted me to take it away and put it somewhere safe. So that's all they wanted. So I left their house on the Wednesday evening and went back to my hotel in Cheltenham that I'd booked on the train over there with 300 grams of fresh carbonaceous chondrite. It did cross my mind just to disappear into the night. So display. So the intention is that when the museum reopens, that it will go on display. But I can't tell you exactly. So it's looking like towards the end of May. But obviously with things at the moment, there's no fixed time, but that is the plan, that for the museum reopening, there will be a piece on display. One of the problems is that, well, that's not a problem, but most of the stones, most of the fragments are very small. So they're not particularly, to us, they're absolutely stunning, but they're maybe not brilliant for a kind of display within a museum. We do have the big stone, which, as I said, is split into two, which is really amazing. That would be the best one to go on display, but it's also really scientifically interesting. So it'll be a discussion is going on at the moment as to what goes on display. But yes, it will. And our plan is that hopefully, later down the line, some will go on display in the Winchcombe Museum, maybe even the Cheltenham Museum as well. And hopefully in some of the other museums, if not a permanent display, a touring kind of exhibition that travels across the UK. So, there's a lot of paperwork for somebody else to fill in before that happens.
Okay, I think we're going to have a break for a moment. So you've really done well. We've had so much questions coming in and comments from the public. It's really, really great interest out there.
Yeah, brilliant.
It's actually amazing. So we're going to let you have a breather. Peter's going to dig a record out and put it on his record player.
Okay.
We'll come back shortly. We've got some from Mary, I hope, and from Andy as well when we come back. Over to you, Pete.
Okay, well, we're going to play a track. I've been looking for a track in the Astro Radio database that reflects comets and meteors. We've only got one with a comet, so sorry we haven't got a meteorite track. But we have got Arion and Ride the Comet.
Oh. There you go. Of course, you could play any rock music.
Quick one. No, first of all, I think Derek on the UK Mon Network actually got a spectrum of this fireball. Is that the first time a fall has actually had a spectrum recorded?
I haven't I thought there was another one, but I haven't checked yet.
Okay.
But it's definitely not common. So yeah, so I've seen Derek Spectrum. We're very excited by it. Derek's been in touch, and we are looking into it. So
so is my husband. We're going to have one on one of our cameras that overlaps with another one soon.
Yeah, brilliant. Yeah. Because it's amazing. So obviously, I mean, this sample has really. So we often ask people to look for kind of black shiny rocks, because most fusion crust is kind of black and shiny, and because it's a carbonaceous chondrite, it's actually more of a kind of matte, dull color. It's definitely black, but in some patches we have really brown staining. Actually, well, I don't know if it's called stain, but it's much browner than it is black. And I've only ever seen that on a few other carbonaceous chondrites, and it's not particularly well understood. I think we think it might be something to do with iron oxides. These meteorites tend to have a lot of magnetite, for example, in them, and it might be something to do with that. So it'd be really interesting to compare when we start looking at the chemistry of the fusion crust, which we will do. It's not a top priority for us normally, the fusion crust, but we will do it. And to compare, for example, with Derek's data will be really exciting. Yeah.
The other quick question was, I think, as far as I understood it, normally the dark flight path in the strewn field isn't made public, but because of COVID this time it was. Is that normal practice, or have I misunderstood? I'm just wondering if it wasn't normal, whether you're going to change that after what's just happened.
Yeah, so the strewn field that was released was very big, and that was Jim basically from UK Fall just kind of going, this is where any meteorites probably would be, assuming that everything just went in a straight line, because that's what should happen. We do have more refined models that we will. So actually, we got those on the Wednesday morning. So we were thinking about going searching kind of later that week, and then obviously with the find, we did that a little quicker than perhaps we were expecting. So yeah, this time has been a really interesting for us, because what we'd really like to do is involve the public and involve people in searching for meteorites. We don't just want the more people you have, the better chance you have of finding it. We don't just want like 10 of us from universities doing this. That provides challenges, because it's not easy to coordinate people and getting school groups and things involved in doing this. But that's kind of has always been in the back of our head, that's how we would do it. And then obviously because of lockdown this time, it just wasn't possible. I won't bore you with how much paperwork and risk assessments went into just getting a few of us out there into the field. It was really, really painful work that actually I was lucky that I didn't have to do most of, but behind the scenes, a lot of stuff went on just to get a small search team out there, just to allow me to go to Cheltenham for the day, really. So we couldn't do it. And in some ways that's been really good for us, because it's kind of we haven't been swamped with hundreds or thousands of people sort of descending on poor old Winchcombe and the local area and traipsing around farmers' fields that they don't want. But we do feel like we've missed out a little bit on getting the public involved, and also getting our PhD students involved and things like that. It's not just the public, it's a whole kind of community in the UK that sort of missed out on that a little bit. So our plan is that next time, hopefully under normal conditions, that we would try and encourage or ask for help with this. And we might not release the strewn field. I might not go on BBC and jump up and down about it, but we'll probably share it with teams that we've put together.
Thank you very much, Mary.
Yeah.
Sorry, Peter, over to you.
Yeah, Andy, did you have one more question?
Yeah, sure. Basically, I mean, theoretically, this meteorite could have ended up in the hands of a collector rather than the scientists.
Yeah.
How do you feel about that? Because that would have been such a tragic loss to science if it had just gone into somebody's dusty collection somewhere.
Yeah. So, again, this is always a debate we have in the community. I would say the vast majority of dealers and collectors do really fantastic work. They obviously, most of them are just very excited by meteorites and the science, and they do fantastic outreach and engagement with their samples, and also many of them, again, kind of under normal circumstances, can react much quicker than we do sometimes. So I'm pretty sure without COVID, we would have had dealers on the ground probably on that Monday morning. I think I know dealers who literally can just get on a plane and drop anything and go searching for these things. So,
right.
So dealers, we also, we work quite closely with dealers. We exchange samples. We'll buy samples from dealers as well from time to time. So we don't have a big issue with dealers. The other thing is for a meteorite to really have any kind of value to anybody. So for dealers to be able to sell it, or for scientists to be able to publish papers on it, it needs to be officially classified. And to do that, some of that material has to be donated to a meteorite repository, which the Natural History Museum is one of those, the Open University also. So we would, for example, if a dealer had found this, they would have to deposit a certain amount of material with us. We would then do the classification of that meteorite. Right. So that kind of guarantees that some material will end up in the scientific community. It doesn't just disappear into somebody's drawer. I think it's very unlikely that there are too many things out there that have just disappeared into kind of
thank goodness for
collections.
And can I just very briefly ask you about what sort of instruments will you be using to analyze it? Have you got things like mass spectrometers and things like this? Yeah.
All the instruments.
All these. Do you? Will you be X-raying it for structure? Yeah.
Yeah. So lots of my work is using X-rays to look at the mineralogy and the crystal structure and
fantastic.
Do a bit of chemistry.
I wish I had your job.
Yeah, it's fun. And we do. Yeah, we have mass spectrometers, and we'll do measuring isotopic compositions of all the different elements. We'll be able to measure the abundance of all the different elements.
Fantastic.
We do things like infrared spectroscopy. So that's basically looking at how the light bounces back. And what we can do is compare that to asteroid surfaces. So that's really important because most meteorites are weathered. So their kind of color has changed just slightly. So to get something fresh and to compare that to asteroids is really important.
It's so exciting, isn't it? Well, good
luck.
Yeah.
So any laser or electron, lots of what we do is electron microscope work. So actually looking at it using electrons rather than, so we probably won't do too much optical microscope work actually, which is the kind of classic geologist tool. But these types of meteorites are really fine grained. So the grain size is kind of on a micron or so in size. So really, really difficult, and they're really dark. So actually, if you look down an optical microscope, there isn't that much to see. It's why you need to start going to X-rays and electrons to actually see anything in there.
I found that out when I tried to look at my AND meteorite under my microscope. It's just
not too bad. At least it's got some chondrules and CAIs in it. TM chondrite doesn't even have those. Not really. So,
I mean, if a meteorite's sold on the black market, does that make it dark matter? Sorry about that. Sorry.
No.
Daz has had that written down for about 6 months. He thought,
he's been waiting.
Off air, we were talking about lightning strikes and all that, and creating the conditions to start life. And I've thought them in the back of my mind. I've just read recently that there's a paper just come out, and it is in the last 5 or 6 days. That's raised its head again, where they've been doing. MIT technology and things, people like that have been trying to recreate the soup and the with lightning and things like that. And they are saying that now there is a very good chance that it was involved in the starting of the life on Earth. So I just thought I'd pop that in there because we were talking about it off air. So
it's carbonaceous chondrites like Winchcombe. That's the things that they'll use in their experiments is the stuff that you'll find in those meteorites.
Excellent, yeah.
Just before we go ask anybody any further questions, I just want to say the point about looking at meteorites under the microscope, I just love it. I've got, just by coincidence, I happen to have a little piece of Mars.
Is that Mars? That's a big piece of Mars.
Wow.
Well, this is. I'll just off the top of my head, this was found in Morocco in June 2012. The actual slice, it's more of an after-eat mint, isn't it? It's as thin as an after-eat mint.
Yeah, that thing's cut polished down. Yeah.
But it says it's 1.97 grams, which not a bad piece. That really.
No. That's for Mars. That's a very big piece.
Now,
that's
what I love about this,
I won't ask you how much you paid for it.
But you said about the cost. Jokingly, I said things are only worth what people will pay for. Are willing to pay for them, and that puts a value on something. This little slice, no one knows where I live, I don't think. So I'm going to say £200 this cost me.
Oh,
that's a bargain. I would say that's a bargain.
That was a bargain.
That is a
and that's
bargain.
because a certain meteorite salesman, Martin Goffert, MSG Meteorites, is an excellent guy.
Yes.
He knows the subject, and he is an excellent man to get in touch with. MSG Meteorites, that is. Some great stuff, but he's also very informative as well, I've got to say. But I'll try and bring it as close as I can to the camera before the image disappears. But you can see those little bits and pieces there.
You can, yeah.
Do you know what type of Martian meteorite it is?
Well, as in the Northwest Africa.
Is it a Sherg? Does it say? Is it a Shergotite or a Chassignite or a Naclite?
Shergotite. Yeah. So what can we define from that? I mean,
I'm
looking at these little particles, and
the Martian
the thing actually is there's little bits of red in there, and I tend to think of them as iron oxide, maybe, but that's my imagination.
They're all kind of basalts, the Martian meteorites, but they probably sample different kind of basaltic layers, and they have slightly different ages, the groups, and the different chemistries. So,
But isn't it cool that on Earth we can actually have a slice of the moon or a slice of Mars? I've also got maybe a slice of Mercury, but that's not been proven yet.
Yes.
Until the information that came back from Messenger seems to indicate that it could possibly be a slice of Mercury.
There is one out there on the market that's an unusual meteorite that's been linked to Mercury. The difficulty, it's not impossible to have a meteorite for Mercury, but it's really hard to get something to get knocked off the surface of Mercury and come back to the Earth.
It's got a long way to come to us.
It's challenging. Well, the sun doesn't really want it to happen.
Not really. No, it tends to have a little jobs. Does affect, I should imagine.
That would have to be ejected at some phenomenal velocity to climb out the gravity well of the sun.
Yeah.
But it's that story. Is people always ask, well, how do you know it's from Mercury? How do you know that this is from Vesta? And how do you know this is from Mars or the moon? Because we've been to the moon, we've been to Mars, we've been to Vesta, we've brought samples. We've actually drilled and taken samples and measured what it's made of. And these meteorites that are found on Earth match it perfectly, 99.999% the same. The one from Mercury is just based on the information that Messenger, I think it was, wasn't it? Messenger done the analysis of the planets and sent its data back, and it seems to agree closely with what it found. But we've never landed on.
I'm guessing it's it's probably classified as an ungrouped meteorite.
But maybe one day, and that value will.
I mean, we had Martian meteorite. I say we, it was before my time, but the Martian meteorites existed for a long time. It was only when the Viking landers got to Mars that they were actually that was the kind of smoking gun, was the composition of the Martian atmosphere matched really well with what was in the meteorites, and that's when they went, okay, these must be coming from Mars. They knew that they were probably planetary because they were basaltic igneous rocks, so they had to come from a big object where you had melting and things going on. So it couldn't come from an asteroid like most meteorites. But
I'm just going to finish with a little comment before we just go on to Daz. If you have one of these meteor rocks or meteorite rocks from Mars, and you've got an air pocket, I'm going to say air pocket. If you've got a cavity inside that rock, that contains the atmosphere of Mars, surely.
Yes, yeah.
That in itself is
that's how they
pretty
identify
cool.
Them. Yeah.
It's like finding one of those prehistoric mosquitoes or whatever in a module of amber or something, it's trapped in time. Sorry, Daz, I'm going on again.
No, you carry on.
Okay then.
After me though. Just a quick one, just another bit of useless information. You held up your bit of Mars meteorite. There's actually just another bit of useless information. On Perseverance, there's a geocache coin with a slice of Mars meteorite actually in it. So for people who like geocaching and going around and looking for all these things, there's a bit of Martian meteorite on Mars, which it doesn't sound right, to be quite honest. But yeah, they sent it back up there, so it's gone home. So
that's a sample from the Natural History Museum.
Oh, is it? Oh, excellent.
Oh, nice.
It was found, I think it was found, I can't remember its name. I think it was found in Oman. So it's a desert meteorite, but it lives in our collection.
And they've sent it home.
They've sent it back. Yeah. It's being used as a kind of calibration target for some of the imaging and things.
Okay then. Oh, excellent. So it's not just sat there for looking.
No.
Yeah, because I know there's quite a few things that they've strapped onto Perseverance for science purposes and things like that.
Yeah.
They never put anything on that isn't for science.
Yeah.
There's no spare weight at all.
Yeah.
It's I just thought that would be a bit of useless information just to put out there so everybody knows.
Interesting. Yeah.
I was just looking for a photograph or an image that I had of a meteorite that I did own back up to 2017, and I went over to America to see the eclipse of the sun. Stayed with friends who basically accommodate us and were great hosts and really made a fuss of us. So I thought, what can I buy them as a thank you gift that they haven't got? Basically, they've got everything. What can I get them that they've not got? And I thought, I'll take over with me a meteorite. And I thought, shall I or shouldn't I? Will they appreciate it? Will they understand what it is that I'm giving them? And I think to this day that they do not understand 100% what I've given them. Now, we're not talking about a meteorite that is 4.5 billion years old. This one was older than the sun. And the only way it could have those particles in it if a supernova had exploded and spread those particles throughout the universe, and they collected in a dustiest solar system and perhaps an asteroid. And when it's dated, its elements are older than the sun, therefore older than our solar system, obviously older than the Earth, 4.7 billion years old. And I tried to explain to them what this is about, and they went, "Oh, that's great, isn't it?" And then they put it on the back of a shelf. And I thought, and I actually said to them when they left, I said, that is very important. One day, hopefully, you'll do some research and find out what that number means and what the details are. Go to this website. You'll find all the information there. And I hope that they have done. The one thing they did say is that they want to keep it and they're not giving it back to me. So maybe they did their homework. And I regret giving it because it was, it was one of those. And I looked at it and I thought, that is older than the Earth. When I look at all those little bits of particles in that slice, I'm looking at something that formed from a supernova in a different star system. That's what meteorites are about.
Not to ruin your story. I don't want to.
Don't ruin it. Tell my story.
So none of our meteorites, none of the meteorites are older than the sun. They are, the sun. The sun comes first, and then the meteorites and the asteroids form. So the meteorites are 4.6 billion years.
Yeah.
But some meteorites do contain what we call pre-solar materials.
Okay.
So that is dust that was formed around previous generations of stars. Some of that dust formed around supernovas. So that is preserved in the really pristine. So meteorites that come from asteroids that really haven't been modified by any heat or any water. We can extract that dust out. It's really tiny, tiny grains. It's not something you can kind of see by eye. But that material is 4.6 billion plus however many billion years you want to
plus
add
or
on.
minus.
Yeah.
But how many extra solar system meteorites are there?
None that we know.
Okay.
No, nothing that's ever been proven to come from outside our solar system. Doesn't mean it's impossible.
No,
that it could happen, but
could do with a chunk of Oumuamua.
Well,
I can't say it. I don't know how to say it.
Nearly did. Oumuamua nearly took us out.
The interesting thing there is if you had a meteorite. So the question is, if you had a meteorite from that body. So I think there was a paper out last week that said it was probably mainly nitrogen ice, and it almost looks like a piece of a planet that's a bit like Pluto, for example. So if we had a meteorite from that, the chances are that none of that material would ever actually make it down to the ground. If it did make it down to the ground, it wouldn't survive for very long, so you'd have to find it really, really quickly. And then if you did find it, how would you identify it as being extrasolar? That's the other interesting challenge, because we don't really know. So this comes back a little bit to talking about the Mercury Meteorite. Is that meteorite, I've never looked at it, but I know it has some unusual properties, and it's proving that comes from Mercury is the challenge. So we don't have any meteorites that come from a comet, for example, that we can prove. We have a few that we suspect maybe could come from a comet, but we don't really know what comets are made from. So this is why having the orbits actually is really important, because if you have an orbit that suggests it came from a comet, that would really help strengthen that argument. But again, anything coming from a comet is unlikely to survive coming through the atmosphere. And if it does make it down as meteorites, it has to be found really quickly.
Well, the orbits have been helpful as well in finding a resonance. Sorry, Mary. So didn't they discover a resonance with one of the debris streams from a meteor shower that has resonance with asteroid impacts on Earth that suggests the big impacts were not fully random?
Yes, probably, yes.
I read a paper on it recently. I think that I can't remember which shower it is though.
Yeah. No, the orbits, all the camera network providing, I'm really interested in the rocks on the ground, but just getting orbits for meteors that don't make it to the ground and understanding the sources of all these different extraterrestrial materials to the Earth is really, really important for kind of unwinding the clock in a way. So we're at 4.6 billion years after everything started, but if we can work out where these dust streams are coming from, we can actually start working out backwards about where that material formed in the solar system and how it's kind of evolved and been moved around the solar system, because the solar system was not static. It used to be like, we used to think of everything as forming where it is now, but there's really good evidence going back to exoplanets. From exoplanets, there's really good evidence that, say, Jupiter and Saturn migrated around the disk a little bit in the first few million years of the solar system. And if you take something as big as Jupiter and you make it move around the disk, you kick all those really small bodies all over the place. So asteroids that formed in the inner solar system get kicked outwards, and stuff from the outer solar system gets kicked inwards. And so the early solar system was really turbulent. It was a real mess. And what we're trying to do now is kind of unravel that information, that story.
A quick question regarding the meteor or asteroid that killed off the dinosaurs 65 million years ago. We were chatting on our last show. Basically, the crater. I'm going to try and pronounce this correctly now, Simon. Are you ready? Chicxulub. Is that correct? The Chicxulub crater. I've been practicing that all day, believe me. Basically, that crater, apart from the iridium that's it's been dated to be about 65 million years and may well have been. They've now said that they've detected meteoritic dust within that layer as well. Have you heard anything of this at all? I'm still trying to find out the details.
So I only half pay attention to it, to be honest.
That's okay. That's more than what I've got.
It's an interesting crater because you can't see it on the surface. It's buried under the sea. And partly on land. So it's mainly was detected by gravity anomalies that actually picked that out. And yes, there was a drilling campaign 5 years ago or so. So they actually went and drilled down, and that's how they're pulling out all these layers from within it. And there's all sorts of interesting impact rocks and structures and things. So so I can't comment specifically on the kind of meteor debris type material in there, but I know, yes, there's been lots of work.
They've definitely found iridium in the core and at the right place from the crater, from the rim of the crater, I think it is, rather than from the center. But really interesting. And that sort of puts the nail in the coffin of the idea that it was anything else that caused. I mean, I think everybody agrees it was probably a mixture of things. For the dinosaurs, the Deccan traps may have contributed to their demise, but the whatever hit the Earth was definitely the nail in the coffin, and now they've more or less proved it with the finding of iridium in the crater itself. So at the right age, obviously.
Yeah, because it's associated as well, isn't it, with the K boundary and the stratification of the rocks and all that.
That's right.
All around the world, and the world is round, by the way. All around the world.
Are you sure?
You've got this K. You've got this boundary of iridium, and it's called the K boundary. And I think there's also a P boundary. I don't know what that one's about, but there. Yeah. Yes, it is round, Dave. Yeah.
Okay, I'll take your word on that. I've got to apologise to Jill over in Dublin because I pinched their question. So sorry, Jill, but a great question all the same. And great minds think alike, eh?
Plagiarism.
I do apologise. Do we have any further questions regarding meteorites, meteors, or meteoroids, or the formation of the solar system?
Just one. Actually, it's because I've lived in Spain for 18 years, so it's quite a while since I went to the NHM, and it is my favourite place in the world, the NHM. And I'm looking forward to taking my 10-year-old daughter there for the first time, which I promised I'm going to do as soon as we're able to, as soon as this crisis dips. Can I ask you about the Barwell Meteorite? Because you've got quite a sizable bit, haven't you, in the NHM of the Barwell Meteorite?
I couldn't tell you what the mass is off the top of my head, but yes, we have some Barwell Meteorite.
Yeah, because that was quite amazing. For our listeners who don't know, this was a meteorite. I've read about the size of a turkey, that exploded over the village of Barwell, which I think is in Leicestershire, if I remember rightly.
Yeah.
And just basically showered the whole village with meteoric fragments. I've read accounts of it going through people's roofs and, you know, just landing everywhere. So we've really got to hope for something like that again. That would be.
Yeah, it was a really interesting. So Barwell was 1965.
Yeah, it was 1965.
It was Christmas Eve. And you're right. It kind of rained down on. So it's the UK's largest recovered meteorite, and it's an ordinary chondrite.
Damn.
And, it rained down these stones all over, and so I've got amazing pictures from the museum team that went out. Kind of, I mean, it was Christmas, so they went out a bit late, but there were lots of reports that some of it hit cars. So people were reporting like they thought there were like gangs of children going around, like vandalizing cars and things. So they went out to look. People found there were some stones, I think, that were found in a vase. So it like bounced off of the tarmac on the road and gone through their window and landed
up in a vase.
A few weeks Sounds like hailstone.
It did make little impact craters. So same with Winchcombe made a very small dent in the Wilcox driveway, and this made some little impact craters in the tarmac and stuff.
How far was it from the front door or the roof of the house? I mean, was it feet away or a meter away or so?
It looked fairly close.
It came over the top of their roof, and I guess they've got quite a big driveway, so I guess it's maybe I don't know, 5 meters or so away from their front door ish.
Oh, pretty close.
It's pretty close, really. Considering,
a lot of averages.
It only just flipped the driveway. Another sort of 5-10 centimeters to the right, it would have landed on the lawn, which would have been interesting. It still would have broken, I think, but we might have had, 3 or 4 pieces rather than hundreds of stones. And I think I sort of said earlier to somebody, that would have been really nice, particularly for display purposes, but it would have been a challenge to curate and distribute. So having lots of little pieces is not necessarily a terrible thing.
And are the Wilcox going to fence off that area of their drive and put a little sign there or something? Because that's what I do. I charge people €10 a look. This is where the meteorite is.
I can't say too much, but we're hoping that the driveway will be coming to the museum.
That's to a museum near you.
Yeah.
Interesting. Yeah.
The house will have to have a blue plaque.
Yeah, that's worth at least a blue plaque.
That's it. But where would you put the blue plaque? On the floor where the driveway is, or on the wall of the house, or on the gates?
Really, don't you? On the floor.
The X marks the spot, or the bullseye, saying, "Well, it hit the bullseye." Yeah. I was thinking when you said about the Barwell where it broke up and basically showered meteor particles down, or meteorites on the ground. I was lucky to be in the Sinai Desert in '99 in November to watch the Leonid meteor shower, and as I've said before on the program, it built up to a crescendo of meteors, just shooting across the sky in every direction. Wherever you looked, there was half a dozen over there. Wherever you looked, there was meteors in the sky, and I can't believe now that none of them actually landed by us or hit us. But, I think they were probably smaller particles, maybe.
Very, very. We probably get 10-20 meteorites recovered, so more than that fall, but most of them end up in the oceans, but only about 10 or 20 recovered meteorites. It's not a very common thing to happen at all. So
it's been absolutely fascinating to learn about the meteor side and meteor rocks and wherever.
It's great.
So we've got about 5 minutes left before Peter takes us out with a bit of music. So just before we go into that, let's just chat quickly about your taste in music, if you don't mind. I'm going to call you Ashley now because we've gone from the doctor side to just Ashley. So what music are you into, Ashley? Because obviously we're a music program as well as an astronomy program.
Good question. So I mean, I'm really into 80s synth. Pop.
Oh right,
a new romantic type thing is but I also grew up. My dad was always a big fan of the Clash and Woodstock and things. So I grew up when I was a teenager. That was my real thing that I first fell in love with. But now big into kind of synths. If you've got a synth, I'm probably there.
Yeah, I'm not too sure. I won't ask for Peter's comments on 80s synthesizer music, pow 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 pow, etc. etc. I think like Mary, Peter likes the bass guitar.
I'm a huge
bass guitar as well. I love a bass and drums.
Oh, and do you play instruments as well?
No, I've never ever been. No, I like none of my family play instruments, so I never kind of grew up with that.
Yeah.
And I always, when I moved back to London last October, and it crossed my mind, particularly with the lockdown, to buy myself a bass. And if I was going to learn, I'd love to learn the drums. That's what I'd love to be. And I have tried, but they're very difficult to learn because if you live in a flat like I always have done.
Yeah.
But the next best thing for me would be a bass guitar. That would.
What can I say, Mary? A bass player. Peter's a bass player.
Mary, your cover of Good Vibrations was superb.
Thank you. I've just put Don't Stop Believing out today as well. So.
Well, you can't win
bit 80s and synthy.
So I'm a huge fan of prospective bass player in the ground.
I'm a huge fan of Thomas Dolby from that era.
Einstein's a Go-Go.
No, that was Landscape.
I like that one.
Yeah. No, he's a fantastic musician, and of course he went on to create the sounds chip that was used in all Nokia mobile phones and since every phone worldwide. He's a very clever guy. Yeah, he's now a music lecturer at Baltimore University of all places. So, and I keep saying to him, keep writing to him, saying when you're going to release a new album, because he hasn't released a new album in the last 10 years. It's about time, but he won't pull his finger out, unfortunately. So, well, actually, it's been fantastic talking to you. It really has. Thank you so much for your time.
No problem. It's been a pleasure.
Yeah, brilliant.
Please come and see us again. I'm going to pass it over to Peter as we end the show.
You're welcome to drop in anytime. We're always here.
Yeah, give me a shout. I'm happy.
Well, we're here Mondays and Thursdays, so just drop in.
Yeah.
Okay, Peter.
Well, I was just going to say 80s synth music. I'll pass absolutely no comment on that one. Being as you're our guest, I'll do that on another show.
He's got to be polite.
For me, good music ended around about 1973, then picked up again when Rammstein came out a few years ago.
Oh, okay. I don't think I've ever seen Rammstein, but I know who Rammstein are.
Yeah.
Actually, if you'd seen them, you would know.
Yeah, I've seen footage. Yeah. I don't think I've seen them live.
Well, an interesting band is the way none of them were rock musicians when they started. They were all folk musicians. Who lived in East Germany, and the way they got famous, what they were doing before the wall came down, they smuggled tapes into West Germany, and then they got a note when the wall came down. They'd already got notoriety, but none of them were rock musicians to start with, and the singer was an East German Olympic swimmer. So they're very, very nice guys, very interesting guys to talk to. But anyway, Dr. Ashley King, it's been great having you on Astro Radio. We want to thank you very much for coming on tonight. And one of the musical choices we made when we had our break was called Ride the Comet, and it was all about extremophiles and things like that. I was listening to the word while it was playing. But we're going to play out tonight with a band called Pre-Med, and this is a track called CERN. And we'll be back on Thursday with Reach Out in Such Space. Thank you to the panel. Thank you to Ashley. And we'll see you Thursday. Good night.
Bye.
Bye. It was actually when I got the invite for this and I saw the name, that's what sold me. The Reach Out.